Talk about image resolution. This is often one of the more confusing topics that digital imaging has to explain, but we're going to get through it step by step and we're going to demystify some of the confusion around this issue. So, image resolution is defined as the pixel count in a digital image. So, common sense would say more pixels is higher resolution in terms of the image, and less pixels are lower resolution in terms of the image. And we have a slide at the bottom here that shows a pixel array going from lower resolution to higher resolution. A 1 by 1 pixel, a 2 by 2 pixel array, which means there's a total of 4 pixels, a 5 by 5 pixel array, and all you would do to get the total number of pixels in a pixel array would just be to multiply. So if we say, look at that 5 by 5, and you say 5 times 5, you would get 25. So there would be a total of 25 pixels within that pixel array, and so on. So the amount of pixels really matters in terms of the resolution of your file. So you always want to make sure that you understand how many pixels your file has and that you're actually working with the correct resolution. Some of the definitions that we're going to be thinking about here in explaining these issues around resolution. A pixel is short for picture element, and it's the smallest component of a digital image. Another definition would be PPI, or pixels per inch. Now, this is very important. You're thinking about pixels in relationship to their display. So in pixels, we're thinking about digital interface. So your screen, projection onto in the classroom, what you look at when you're looking at your phone. This is displayed in relationship to pixels, and each of these display mechanisms has its own resolution. So the screen that I'm looking at right now has a specific native resolution, and your phone that you might be looking at has a specific native resolution, meaning that it'll display a certain number of pixels per inch. And what this means in relationship to your file is that your file could have more pixels per inch than your screen can display, or it might have fewer pixels per inch than your screen can display. So we'll think about that when we're looking at our files in Photoshop. Another term that we are going to learn is DPI, or dots per inch. Dots have everything to do with the ink dots that an inkjet printer can spit out in a line per inch. So this is very different than pixels per inch. Dots is defined as these little bitty specks that a printer can spit out. So this is how it translates that digital information to actual ink and color on a photograph. Finally, megapixel, or MP, is just defined as a million pixels. So if we're thinking about what kind of camera we want to buy, and we say, oh, I have a camera with a sensor that is 20 megapixels. Well, all that means is that every time you take a photograph, it's creating 20 million pixels. And the more megapixels a camera sensor is, the more you're going to pay for it, because each time it captures an image, it's collecting that much more information. So the latest camera on the latest phone, they're really going to brag how many megapixels the camera is. And that all means is that it's actually shooting at a higher resolution. It's gathering more pixels every time it takes a shot. So let's get out of this mindset and think about how this translates in terms of how we're going to use images for this class. So 72 to 100 resolution is images that are made for the web. So these are made for digital screens, and this is regarding output. So you're going to be changing resolution in terms of the context of the image. So if you want to make an image and put it on a website or share it on Instagram or do anything that you want to do with it for digital screens, 72 to 100 resolution is what you need. Anything more than that would be overkill. It would mean that you're just making people download more information, more storage, and it's going to slow down everything. So this is matching the resolution of a computer screen, which is really good because that's what we're looking at when we look at these images. However, the printer sees resolution very differently, and it needs a higher resolution in order to translate that information to dots. So when we're making our files ready to be printed, a good resolution is 300. 300 is a high enough resolution to translate all those pixels into enough dots that will make a beautiful photograph. So those are the two main resolutions that we're going to be dealing with. 72 to 100 for digital screens and 200 to 360 for a photograph. Could resolution be higher than 360? Of course it could, but the printer only sees this range of resolution. Anything lower than 200, you're going to start to see an image that is quite pixelated. But between this range of 200 and 360, you'll see a nice, sharp, high resolution image. A higher resolution than 360, the printer will actually be able to read that, but it will not look any different at all. So then you're just dealing with more information than you need, and that's something that is inefficient, and we're not going to be able to store many of those files if we save them at a higher resolution than needed. So let's take a look at what's happening underneath the hood here. I'm going to open up